Hello, kids. So we are moving on to one-step equations with addition and subtraction. I'm sure you have done these or are doing them currently in your math class. So I'm going to go over 4 examples for you with different situations with addition and subtraction and one-step equations. And then there are a few problems after that for you to complete and submit on Schoology. Before you work this assignment, you should have already watched the Play Pause It video, math antics of how to do one-step equations with addition and subtraction. Okay, so here we go. Example number 1, 6 plus x equals 9. All right, so we will start. So the point is we want the variable by itself. Okay, so we don't know what that value is. So in order to solve for this equation and find out what it is, we need to get it by itself on one side of the equal sign. So we need to get rid of everything that's in that expression, 6 plus x. And we want to use opposite operations. Okay, that's the key here, opposite operations. So we see addition. Okay, we have a positive 6 plus x. So we want to subtract 6 from both sides, and then we can get rid of that 6 and leave the x by itself. So I like to set it up like a problem, and I'm going to subtract 6 from both sides. I like to think of these equations as a seesaw, okay? And we want the seesaw to be nice and balanced, okay? So we can take it up. This guy's going to stay down, then he can go up, and then this guy's going to go down. All right, but in the end, we want to keep the equation balanced, which means that we have to subtract or add, or when we get to multiplication and divide or multiply on both sides of the equation. That's the only way we can keep it balanced. So we subtract 6 from one side, then we must subtract it from the other side. We'll get rid of that. All right, so this cancels out. 9 minus 6 is 3. Bring everything else down. So we have x equals 3. And if we wanted to test that, it would be super easy. We could do it in our heads. If x equals 3, 6 plus 3 is indeed 9, and 9 equals 9. So we know our equation is balanced. Example number 2, x minus 4 equals 3. We're remembering opposite operations. So we have subtraction here with the negative 4. So we would like to add 4 to get rid of it. So we'll add 4 to one side plus the other side. And then the 4's cancel. And 3 plus 4 is 7. Bring everything else down. You don't have to draw these arrows, but I like to indicate what I'm doing in the problem. And so we're left with x equals 7. And if we did 7 minus 4, that is 3. So we know that our problem checks out. Example 3, x minus 5 equals negative 2. All right, so opposite operations, I have a negative 5 or a minus 5. So I would like to add 5 to both sides. And this is where we have to be careful because we're adding negative numbers. So negative 2 plus 5, if you can't see right away that equals positive 3, you can do a little number line, jot down a little number line. We're starting at negative 2, 0, say, is here, and then we'll just make a few more ticks. This would be 2, 4, you little ones here for 1 and 3, negative 1. All right, so if I'm adding 5, it means I'm going toward the right on the number line, okay? Positive toward the right, negative toward the left. So we're starting at negative 2, and if we go 1, 2, 3, 4, 5 units to the right, we are left at positive 3. All right, so negative 5 plus 5 cancels out, and we are left with 3. Bring everything else down, and x equals 3 is our answer. And if we check that, 3 minus 5 is indeed negative 2, so our equation is balanced. And the last example for you, 8 minus x equals 4. You saw an example like this on the Math Antics video, so I wanted to do one for you. So this looks a little bit different than some other equations. It's kind of a curveball, if you will. Now, we could subtract 8 from both sides because we have a positive 8, all right? And I'll show you what that would look like. If we subtract 8 from both sides, 8's cancel out, and 4 minus 8 would be negative 4. But we're left with this negative symbol, and that negative symbol is not going to suffice for having not going to be sufficient for having our x on one side by itself, because that negative sign in front of the x technically means a negative 1x, and we need 1x because we need the number, the variable, whatever is going to be multiplied by that variable would equal the number itself, the variable itself. So negative 1 times x would make that value, the unknown value of x, a negative number, and that's not what we want. We want the value to be unchanged. So we would have to get rid of that negative and be left with 1x in order to keep that x variable the same. So instead of doing that, now if we wanted to continue, we could solve it this way. We would have to divide negative 1 by both sides, and we would have the negatives would cancel out. We would have x equals 4 because, 4, because of course a negative divided by a negative cancels the negative. All right, so we solved it that way. We have x equals 4. We'll see if that's right, but I want to show you the more sensible and easier way to solve this problem. So bear with me just a moment. Okay, so can we add a variable to both sides? Well, sure we can, because we don't know the value of that variable, but as long as I add, subtract, multiply, or divide on both sides of the equation, then we're not changing the value of the equation. It's going to stay balanced. So let's add x to both sides and see what happens. All right, so x's cancel out. We'll bring down our 8, bring down our equal sign, and then we have 4 plus x. And now we have this thing called commutative property, which tells us that when we're adding, we're doing an addition problem, we can switch the values on both sides of the plus sign, and we'll be left with the same answer. So 4 plus x is the same thing as x plus 4. Now, we can't do the commutative property with subtraction, because 8 minus x is a different problem from x minus 8. Okay, you have a positive 8, and if I change it to x minus 8, I have a negative 8. All right, so it only works with addition and multiplication and not division or subtraction. Okay, so this means that I could, if I wanted to, I could write this x plus 4, and then it would look like we're used to seeing it. What's happening? X plus 4. All right, and so that way, when I finish this problem, and I'm just going to write this up here so that I have room. Now we're using opposite operations. We have a positive 4, so let's subtract 4 from both sides. And 4's cancel out. We'll bring down the x, bring down the equal sign. 8 minus 4 is 4. And indeed, x does equal 4. That's what we saw before when we worked the problem out the other way. And that's that. All right, so all you have left is the problems to do underneath. Please finish that and submit. And bye for now.